Ever heard that story about Galileo, after being forced to recant, muttering, and yet it moves?
Ah, yes, the famous Eppur si muove.
Turns out that's probably just a legend.
Likely, yes, but his actual story. It's packed with surprises way beyond just the church conflict.
Totally. Okay, let's get into this. Today in the deep dive, we're looking at a really detailed Wikipedia entry. And get this, it's in Vietnamese to really pull out the key stuff about Galileo.
That's interesting in itself, using a source from a different perspective.
Right. We want to get past that simple science versus religion thing and, give you the express route to understanding Galileo di Vincenzo Bonajuti di Galilei.
The man Stephen Hawking said was responsible for, well, the birth of modern science. Quite the statement.
Exactly. Father of modern observational astronomy, father of modern physics. The labels are huge.
And it's fascinating, isn't it? When you dig into someone you think you know, especially through a detailed source like that, you uncover layers, connections you hadn't seen.
It makes you realize just how much his work still, resonates today.
Absolutely. It's not just history. It's the foundation of how we see the universe.
Yeah. So these grand titles, what were the building blocks? His early life, maybe?
Yeah, let's start there. He was born in Pisa, 1564. Galileo di Vincenzo Bonajuti di Galilei, that was his full name. And his family background, especially his father, Vincenzo Galilei, seems really influential.
What does his father do?
He was a musician, a lutenist, and a music theorist. But critically, he also conducted experiments. Actual experiments on things like vibrating strings.
Experiments in music.
Yes. And apparently, these experiments led to what's considered maybe the first non-linear relationship documented in physics. Think about growing up with that music and math and actual hands-on testing all mixed together.
Wow, okay, that paints a different picture. Not just dusty books, but sound and measurement. Did that push him straight into science then?
Not immediately. There was some talk of him joining the priesthood, actually. And his dad wanted him to study medicine, which he started at the University of Pisa.
Medicine.
Yeah. But then he found mathematics. And that really clicked for him. That led him to teaching jobs, first back in Pisa, and then importantly at Padua.
Padua was a big deal for him, wasn't it?
Definitely. A really productive period. A lot of his key scientific work, both thinking and doing, really took off there.
Now, outside of the academic world, the Vietnamese source mentions his personal life, his relationship with Marina Gamba.
Right. Even though he was a devout Catholic, he had this long-term relationship with Marina Gamba. They had 3 children together.
3 kids.
Yeah, 2 daughters, Virginia and Livia, and a son, Vincenzo. But because they weren't married, well, the social rules back then were harsh.
Ah, so the illegitimacy caused problems.
Big problems, especially for the daughters. Galileo felt they couldn't marry well, so both ended up in a convent, San Mateo in Arcetri.
For life.
For life. Virginia became Sister Maria Celeste, and she actually remained incredibly close to Galileo, writing letters, supporting him, especially later during his house arrest.
That's quite poignant. And the son.
Vincenzo was eventually legitimized, yeah, married.
Yeah.
It just shows, even these towering figures lived within real-world constraints.
Absolutely. Grounded in human reality. Okay, let's shift to his tech side. The telescope is the obvious one, but he was quite the inventor, wasn't he?
Oh, definitely. He wasn't just looking through instruments, he was making them and making them better. He took Lippershey's early telescope design and just ramped it up massively.
Better.
Up to like 30 times magnification. Suddenly you could see things nobody had conceived of before. And he was smart about it, showed it off to the Venetian bosses, highlighting how useful it could be for spotting ships, for trade, for defense.
Right, practical applications. Smart move.
Exactly. It wasn't just about the stars. It had immediate value. And then beyond the telescope, around 1624, he comes up with the compound microscope.
A microscope, too.
Yep.
Giovanni Faber, part of that scientific society, the Accademia dei Lincei, actually coined the name microscope for Galileo's device. And his was apparently the first one used for, proper biological drawings. Imagine opening up that whole tiny world.
Incredible. 2 fundamental instruments, telescope and microscope. What else did our source mention? Any other gadgets?
Oh, yeah. He invented a geometric and military compass, super useful for gunners, surveyors, map makers. He made an early type of thermometer called the thermoscope.
Thermoscope.
And he had this brilliant, if maybe ahead of its time idea, to use Jupiter's moons.
The ones he discovered.
Exactly. To use their predictable orbits as a kind of universal clock to figure out longitude at sea. The tech wasn't quite there to make it work practically, but the concept was ingenious.
Wow. thinking about global problems.
Towards the end of his life, even under house arrest, he designed an escapement mechanism for a pendulum clock. And there were sketches, apparently, of other little inventions. A light reflector, maybe a potato peeler.
The potato peeler,
Yeah.
seriously. Well, the source mentions it. And a folding comb, even something that looked like a ballpoint pen concept. It just shows a mind constantly buzzing with ideas, big and small.
A true Renaissance man, tinkering away. Okay, let's fly out to the cosmos now. His telescopic discoveries,
Yeah.
game-changing, doesn't even cover it.
Absolutely. Observing Jupiter's 4 big moons, Io, Europa, Callisto, Ganymede, and tracking them. That was huge.
He called them the Medici stars first,
Oh.
right? Bit of patronage there.
Yes.
Right.
Smart politics again. But the scientific implication, it was a direct hit on the geocentric model. Here's Jupiter, clearly with its own little system of bodies orbiting it, not Earth.
Right, undeniable proof that not everything went around us.
And he got pretty good at calculating their orbits over time, which just solidified it.
Then Venus. The phase of the Venus seemed crucial, too.
Oh, incredibly. Observing Venus go through a full set of phases, just like our moon crescent, half gibbous full, that was something the old Ptolemaic system just couldn't explain.
Why not?
Well, in Ptolemy's model, Venus circled a point between Earth and the Sun. From Earth, you'd only ever see it as a crescent or maybe new. Seeing a full Venus meant it had to be going around the Sun, sometimes behind it from our perspective.
Got it. So direct observational evidence favoring Copernicus.
Exactly. It didn't prove Copernicus 100% on its own, but it dealt a massive blow to Ptolemy, made the sun-centered view much, much harder to ignore.
What about other planets? Saturn.
Saturn puzzled him at first. His early telescope wasn't quite sharp enough. He saw the rings, but thought they were maybe 2 smaller moons or handles on the side of the planet. Described it as triple-bodied.
Years.
Sort of.
Yeah.
And later, when the rings were edge-on and seemed to vanish, he was completely baffled, thought they'd disappeared.
And the sun itself. Sunspots.
Yeah, he was one of the first Europeans to observe sunspots systematically. Got into a bit of a row with Christoph Scheiner, a Jesuit astronomer, about who saw them first and what they meant.
But what was the big deal about spots on the sun?
Well, the old Aristotelian view was that the heavens were perfect, unchanging spheres. Sunspots were blemishes, imperfections. It suggested the sun was dynamic, not some flawless orb.
Okay. Challenging perfection.
And watching them move across the sun's face showed the sun rotated, which Kepler had actually predicted. Plus, the way their paths seemed to change over the year gave more evidence against a purely Earth-centered universe. So, yeah, spots matter.
And our own moon. Not so perfect either.
Not at all. His telescope showed mountains, craters, a surface he described as rough and uneven, much like Earth, again completely shattering the idea of smooth, perfect celestial spheres.
He basically rewrote the rule book for the moon.
Pretty much. He
Yeah.
also looked at the Milky Way and saw it wasn't just a hazy cloud, but countless individual stars. Mind-blowing at the time. And fascinatingly, he actually observed Neptune back in 1612.
He saw Neptune.
He saw it, yeah, but didn't realize it was a planet. Just logged it as a faint, unmoving star in his notes. Imagine being the first to see it but not know what you're looking at.
Wow. So close. It feels like he was just systematically taking apart the old universe, piece by piece. But he wasn't just an astronomer, right? His physics work was fundamental, too.
Absolutely fundamental. And the key thing here was his insistence on combining math with actual experiments. That quote from Il Saggiatore about the universe being written in the language of mathematics, triangles, circles, that was revolutionary thinking.
The Leaning Tower of Pisa experiment, fact or fiction?
Probably more of a thought experiment or maybe a small demonstration, not the grand public spectacle often depicted. But his work on freefall was crucial. He established that objects accelerate uniformly in a vacuum, regardless of their mass.
Which goes against common sense, or at least Aristotle.
Totally against Aristotle, who thought heavier objects fall faster. Of course, people like Lucretius, centuries before, and Stephen, closer to his time, had ideas about this, but Galileo really nailed the concept of uniform acceleration.
And the astronauts on the moon proved it.
Exactly. Dropping the hammer and feather, perfect demonstration. No air resistance.
Did he quantify this acceleration?
Yes, he worked out the mathematical relationship. Distance fallen is proportional to the square of the time. Dion. That was huge. Again, others like Oresme and de Soto had touched on similar ideas centuries earlier, but Galileo gave it rigorous mathematical treatment.
And inertia. That was his, too.
He formulated a clear concept of inertia. An object stays in motion unless a force, like friction, acts on it. This was a massive break from Aristotle, who thought you needed a continuous force to keep something moving.
So setting the stage for Newton.
Absolutely. Newton built directly on Galileo's idea of inertia for his first law of motion. Though, philosophically, ideas about inertia had been around for centuries. Ibn al-Haytham, Buridan, even back to Mozi in China. But Galileo put it into a physical, testable framework.
What about pendulums? I remember something about him as a swinging lamp.
Yeah, the story goes he watched a lamp swinging in Pisa Cathedral and noticed the time for each swing seemed constant, regardless of how wide the swing was. He claimed pendulums were perfectly isochronous.
Was he right?
Mostly, but not perfectly. Christian Huygens later showed it's only really true for small swings. Still, Galileo's insight was vital for developing accurate clocks.
He even tried to measure the speed of light.
He did. A famous experiment with lanterns on distant hills. He understood the method might not be precise enough given how fast light must be, but the attempt itself was groundbreaking. Thinking about how to measure something seemingly instantaneous, the Accademia del Cimento later tried a similar, improved setup.
Just relentless curiosity. What about his theory of tides? I heard it was a bit off.
It was, yeah. He thought tides were caused by the sloshing of oceans as the Earth rotated and orbited the sun. He actually saw it as proof of Earth's motion.
So tied to his heliocentrism.
Exactly. Einstein apparently found his arguments fascinating, even though they were wrong. The big flaw was it only predicted one high tide a day, not two.
And he dismissed Kepler's idea about the moon's influence.
Completely. Called it idle imaginings or something similar. Funny how even geniuses can miss things. But maybe one of his most profound physics contributions was the principle of relativity.
Relativity. Like Einstein.
The Galilean principle of relativity. The idea that the laws of physics work the same way whether you're standing still or moving at a constant speed in a straight line. Think about being on a smoothly moving ship. You can toss a ball up and it comes straight down, just like on land. That concept is bedrock for classical mechanics, and yeah, it leads towards Einstein's theories later.
Okay, physics, astronomy. The Vietnamese source also mentioned his work in mathematics itself.
Right. He mostly used the tools available at the time, Euclidean geometry, theory of proportions, but how he applied that math to describe physical phenomena, that was the real innovation.
And something called Galileo's paradox.
Ah, yes. A really neat observation about infinity. He pointed out that you can match every whole number, 1, 2, 3, 4, with a perfect square, 1, 4, 9, 16. 1 maps to 1 squared, 2 maps to 2 squared, 4, 3 maps to 3 squared, 9, and so on. There's a 1-to-1 match, which seems to imply there are just as many perfect squares as there are whole numbers.
That feels wrong. There are gaps between the squares.
Exactly. It's a paradox of infinity. Intuitively, there should be fewer squares. It took Georg Cantor and his work on different sizes of infinity centuries later to really grapple with that properly.
Mind-bending stuff. Okay, we have to talk about the conflict with the church. It's probably what he's most famous for, unfortunately. Our source mentions specific Bible verses used against him.
Yeah, that was central to the opposition. Passages in Psalms and Ecclesiastes that talk about the earth being fixed or the sun rising and setting, and a key one in Joshua where Joshua commands the sun and moon to stand still.
How did Galileo respond to that? He was religious, right?
Oh yes, deeply religious. He argued, using thinkers like St. Augustine, that the Bible wasn't intended as a science textbook. Scripture tells you how to go to heaven, not how the heavens go, was a line often used. He suggested the authors wrote in everyday language, describing appearances from an earthly perspective.
But that wasn't enough.
Apparently not for everyone. His interpretation of the Joshua passage especially seemed to really provoke his opponents. The attacks escalated.
Leading to the 1616 injunction.
Right. He went to Rome to defend himself, but the outcome was Cardinal Bellarmine on behalf of the Inquisition, telling him formally he had to abandon the idea that the earth moves and the sun is stationary. He couldn't hold, teach, or defend Copernicanism as physical reality.
But he could discuss it hypothetically.
That seems to have been the nuance, yes, and for a while he kind of lay low. But then a friend, Cardinal Barberini, became Pope Urban VIII in 1623.
Ah, that must have seemed like an opportunity.
It seems Galileo thought so. He felt encouraged and started writing his big book, The Dialogue on the Two Chief World Systems. He even got official permission to publish it after some edits in 1632.
So it seemed okay, but then, disaster. The Pope felt insulted.
That's the story. Pope Urban had apparently asked Galileo to present both sides fairly, not definitively endorse heliocentrism, and importantly, include the Pope's own arguments for the traditional view.
And Galileo didn't.
Well, in the dialogue, the character defending the old Aristotelian Ptolemaic view is named Simplicio, and he often comes across as, well, a bit simple, a bit foolish.
Oh dear.
And unfortunately for Galileo, some people, including the Pope himself it seems, felt Simplicio's arguments, especially near the end, sounded suspiciously like the Pope's own arguments, presented only to be easily knocked down. The Pope felt mocked and betrayed.
By someone he'd supported.
Exactly, so the mood shifted dramatically. Galileo was summoned back to Rome in 1633, this time for trial.
The famous trial for heresy.
Well, technically, vehemently suspect of heresy. The charge was basically violating the 1616 injunction by teaching and defending Copernicanism.
And the outcome.
He was forced to abjure, to publicly renounce his belief in a moving earth and stationary sun. His dialogue was banned, and he was sentenced to house arrest.
For the rest of his life.
Yes. That's when the "Appur si muove" quote supposedly happened under his breath, but again, no real evidence for it. Despite the confinement, though, he kept working. That's when he wrote Two New Sciences, another incredibly important book on mechanics and motion.
Amazing resilience. And he died under house arrest.
He did in 1642. Because of the church's condemnation, he wasn't initially allowed burial in the main family tomb in the Basilica di Santa Croce in Florence.
But he's there now.
Yes, they moved him in 1737 to a grand tomb. But during that move, they took some souvenirs.
Souvenirs? Like what?
A few fingers and a tooth were removed from his body.
Seriously. Where are they now?
One of the middle fingers is actually on display at the Museo Galileo in Florence. A bit macabre, maybe?
Definitely memorable. Our source also mentioned how the church eventually sort of came around. A rehabilitation.
It was a very long, slow process. The ban on printing his dialogue eased in the 1740s. The general ban on heliocentric books was lifted from the Index of Prohibited Books in 1758. Those specific bans on uncensored versions of Galileo and Copernicus lingered until 1835.
Wow, 1835. That's
Yeah.
late.
Yeah. Then, in the 20th century, popes started acknowledging the church had mishandled the affair. Pius XII, John Paul II, Benedict II all made statements. Pope John Paul II gave a formal apology in 1992, regretting the errors made.
And talk of a statue at the Vatican.
There has been talk, yeah, and a symbol of reconciliation between faith and science.
A long arc indeed. So wrapping up, what's his lasting legacy? What stands out?
Well, obviously the Galilean moons of Jupiter are named for him. Countless scientific things bear his name.
Got
The
it.
Galileo space probe, the Galileo satellite navigation system, the Galilean transformation in physics, the Gal unit of acceleration.
So embedded in science itself.
Deeply. The UN's International Year of Astronomy in 2009 was timed for the 400th anniversary of his first telescope observations. His life inspired art, like Brecht's famous play Life of Galileo. He's been on coins. But fundamentally, it's his method, that insistence on observation, experimentation, and mathematical description, that really forms the bedrock of modern science.
So if we boil it all down from this deep dive,
Yep.
what are the absolute key takeaways? What should stick with you?
Okay, I'd say. First, his incredible fusion of theory and experiment. That wasn't the norm, he made it central. Second, his sheer technological brilliance, improving the telescope, developing the microscope, opening new ways to see. Third, the complexity of the church conflict. It wasn't just simple goodies and baddies. It was theology, politics, personality clashes, and science all tangled up.
More nuanced than the bumper sticker version.
Way more nuanced. And finally, just the sheer breadth and depth of his impact. Astronomy, physics, math, the scientific method itself. He fundamentally changed how we investigate and understand the universe.
Thinking about Galileo's whole journey, the amazing discoveries, but also that intense conflict with powerful institutions, it really makes you wonder, doesn't it? How do we handle it today when science pushes against established ideas or beliefs? What can his story teach us about balancing that drive for knowledge with societal acceptance? Something definitely worth mulling over as you continue your own quest for understanding. Thanks for diving deep with us.